Hey everybody, this is Mrs. Snook with section 5.1, using fundamental trig identities. We're going to recognize and write our fundamental trig identities, and we're going to use these identities to evaluate trig functions, simplify them, and rewrite them. And these skills will come in handy when we get to section 5.3 and we're solving trig equations. So first thing is we are going to use identities to evaluate a function, and our first one is secant of x equals -3/2, and tangent is greater than 0. And we're going to find the values of all 6 trig functions. Well, right away, since secant of x equals -3/2, I know immediately that cosine of x equals -2/3. Because keep in mind, those two are reciprocal functions. Next thing I'm going to do is I'm going to find the sign, and here's where our trig identities come into play. Sine squared x plus cosine squared x equals 1. I'm providing you with a handout that lists the different identities that you need. So you can refer to your handout to see where this comes from, or if you have your book, go to page 350 in your book. And so then, because I know this identity is true and I know what cosine of x is, I can just plug in and solve for sine of x. So sine squared of x plus -2/3 squared equals 1. And I get sine squared x plus 4/9 equals 1. And then from there, I just subtract 4/9 from both sides. So sine squared x equals 5/9. Now I'm going to square root both sides. So sine of x equals plus or minus √5/3. I'm doing plus or minus because the rule of thumb in pre-calc is when you have to put in the square root, you take plus or minus. Now I'm only going to have one of these as answers, so now I'm going to look at my tangent. I know my tangent has to be greater than 0, but my cosine is less than 0. That means that my sine also has to be less than 0, because a negative divided by a negative is a positive. So my sine of x is -√5/3. Okay, next I'm going to do tangent. Tangent of x, that's the sine of x over cosine of x. So I get -√5/3, and that's divided by -2/3. So keep in mind, when you are dividing complex fractions, what you're going to do is flip and multiply. So -√5/3 times -3/2. My 3's cancel, so I get √5/2. So now I have my tangent of x. So this is tangent of x. From there, I can get cotangent of x right away. Is going to be 2/√5. Remember to rationalize. So √5/5. I get 2√5/5. Only one left, and that is the cosecant of x. And I'm going to get that straight from my sine, which I knew is -√5/3. The cosecant of x, I'm just going to flip over the sign because they're reciprocals, so I get -3/5. And rationalize, I get -3√5/5. So here's our final answers. We have cosecant's 2/3, sine is -5/√3, cosecant is -5√3/5, tangent's √5/2, cotangent is 2√5/5. All right, now we're going to simplify this trig expression. First thing I want you to notice is you see how there's a sine of x and a sine of x? So that right there, I can pull out a GCF. So when I do that, I get sine of x is cosine squared x minus 1, because I'm just pulling out that sine of x. Now I'm going to go back to my Pythagorean identity. Sine squared x plus cosine squared x equals 1. This is one of our identities. And in this form, I can't plug it in right away. But watch what happens if I subtract cosine squared of x from both sides. So I get sine squared of x equals 1 minus cosine squared of x. Now in my equation, I have cosine squared of x minus 1. And here I have 1 minus cosine squared of x. Those are backwards. So what I'm going to do is I'm going to multiply both sides by a negative 1. So I get negative sine squared x equals negative 1 plus cosine squared x. So I'm just distributing this negative. I can then change the order. I can put the cosine squared first. Now that matches. So I can substitute the cosine squared x minus 1. Sorry, I can substitute my negative sine x in for the cosine squared x minus 1. So I have sine of x times a negative sine of x. That then becomes negative sine squared x, and this is simplified. Next one, we're going to factor some expressions. I'm going to separate out some space for me. First one is secant squared x minus 1. I want you to notice this is a perfect square. This is also a perfect square. That's a minus, so it means difference. So this is a difference of two squares. Which means right away, I can factor it like this. I put down my two parentheses. I take the square root of my first term, which is secant x. I take the square root of the last term, 1, 1. 1's plus, 1's minus. Okay, this is done. Here's our answer. The other one, this one's a little bit more challenging. I would encourage you to do what's called change of variable. This is a tool that mathematicians use to make their work simpler. And so when I do a change of variable, I'm just going to make up a new variable. I'm going to call it g. And I'm going to say g is the tangent of x. So now when I put in g everywhere for tangent of x, look what I get. I have 4g squared plus g minus 3. I can factor that with slip and slide. Okay, so let's go ahead and factor. So I slip my 4, I get g squared plus g minus 12. And then factor that. So I get a g minus 4, g plus 3. So that's the slip. Now the slide, I have to undo what I did. So I'm going to divide by 4. And this becomes g minus 1. And this one bottoms up, so I bring the 4 in front, so I get 4g plus 3. So now I've got it factored, but my original problem was in terms of tangent x. So I'm going to go back And I'm going to put tangent x back where it belongs. So I had used g, that's going to be tangent x. So tangent x minus 1 times 4 times the tangent of x plus 3. And this is factored. Okay, we're going to factor another one. This one is cosecant squared minus cotangent x minus 3. Now for me to factor this one, I would really like these trig functions to be the same. So I have a cosecant here and a cotangent here. So I'm going to grab another one of our trig functions. This one says that cosecant squared x plus 1 equals cotangent squared x. So I'm going to go ahead and instead of cosecant squared x, I'm going to put in 1 plus cotangent squared x. So this becomes 1 plus cotangent squared x minus cotangent x minus 3. I'm then going to combine some like terms, so I get cotangent squared x minus cotangent x minus 2. Now last time I did something like this, I did a change of variable. Let's see if we can do it without changing our variable. So cotangent squared x goes in for my first term. I have a minus 2. I want factors of negative 2. One will be positive, one's going to be negative, and they need to add to negative 1. So I'm going to use 2 and 1. So this factored is cotangent x plus 1 times cotangent x minus 2. Okay. All right, now we're going to simplify this expression. And right away, I see this cotangent here, and I know that I can rewrite that as cosine over sine. So I'm going to start with that. So sine of x plus cosine x over sine x. And I'm going to go ahead and leave the cosine x in the numerator. You can think of this sine x as over 1. And so now what I want to do is I want to get a common denominator. And that common denominator is going to be sine of x. So here, cosine x times cosine x is cosine squared x. And then when I put sine of x over 1, when I put that over sine of x as the denominator, I have to multiply by sine of x. So I get sine squared x right here. I can now combine these into one fraction. And we're going to use a trigonometric identity. It happens to be my favorite one. It's the one that says sine squared x plus cosine squared x equals 1. That's my favorite trig identity, because that tells me that my numerator, all of that reduces to 1. This is 1 over sine x. That is the same thing as cosecant x. And we're done. Okay. Last one is we are going to make this one not equal, not as a fraction. So I'm starting off as a fraction, and basically I want to get rid of that denominator. So here's what I'm going to do. I know from previous units that I am allowed to multiply a fraction by another fraction, and I want to keep my numerator and the denominator of this other fraction exactly the same. That allows me to multiply by a form of 1. So I'm going to play a little sneaky snook trick. I'm going to use 1 minus sine of x. I'm using the conjugate, and the reason I'm going to do that is that's going to allow me to have something super cool in my denominator. So let's go ahead and multiply this out. So 1 times 1 minus sine of x is 1 minus sine of x. And then here I have 1 plus sine x, 1 minus sine x. That's going to be a difference of 2 squares. So I'm going to get 1 minus sine squared x in my denominator. Now here's our secret sauce. Let's go back to my favorite trig identity. Sine squared x plus cosine squared x equals 1. Remember that? So subtract sine squared from both sides of this. So cosine squared x equals 1 minus sine squared x. So guess what? I can substitute cosine squared x for my denominator. So now I get 1 minus sine of x over cosine squared x. See how that works? Okay, so the next thing I'm going to do, since I've got it over cosine squared x, I'm allowed to split this fraction into 2 other fractions. So 1 over cosine squared x minus sine x over cosine squared x. Get this out of the way. 1 minus cosine squared x, well, remember cosine and secant are reciprocals, so I can just call this secant squared x minus, and here I have a sine x over cosine x and a 1 over cosine x. So what I'm doing here is I'm pulling out this tangent. So this is secant squared x minus tangent x. And then the 1 over cosine x, well, that's just another secant x. So now I've rewritten this without a denominator. This is no longer in fractional form. So this one is done. All right, that is it for today's lesson. Thank you for watching and have a great day.